Mastering statistical analysis techniques. Histograms hold the secret to unlocking operational excellence, but only if you know how to wield them. When conducting statistical analysis as a means of achieving operational excellence, how does one effectively utilize histograms to visualize and understand data, thereby gaining insightful and actionable information from the dataset? When conducting statistical analysis as a means of achieving operational excellence, effectively utilizing histograms is a crucial step in visualizing and understanding data, thereby gaining insightful and actionable information from the dataset. To begin with, histograms are a type of graphical representation that display the distribution of a single continuous variable. They are constructed by dividing the range of the variable into intervals, known as bins, and counting the number of observations that fall within each bin. The resulting graph displays the frequency or density of the observations within each bin, providing a visual representation of the underlying distribution of the data. The first step in effectively utilizing histograms is to select the correct bin width. The bin width should be chosen such that it is wide enough to provide a clear representation of the underlying distribution, yet narrow enough to reveal any underlying patterns or structures in the data. A bin width that is too wide may obscure important details, while a bin width that is too narrow may result in a graph that is too busy and difficult to interpret. Once the bin width has been selected, the histogram can be constructed. There are several types of histograms that can be used, including frequency histograms, density histograms, and cumulative histograms. Frequency histograms display the number of observations within each bin, density histograms display the proportion of observations within each bin, and cumulative histograms display the cumulative proportion of observations up to each bin. When interpreting a histogram, it is essential to examine the shape of the distribution. A normal distribution, characterized by a bell-shaped curve, is often indicative of a stable and predictable process. A skewed distribution, characterized by a non-symmetrical curve, may indicate the presence of outliers or a non-random process. A bimodal distribution, characterized by two distinct peaks, may indicate the presence of two distinct subpopulations within the data. In addition to examining the shape of the distribution, it is also important to examine the location and spread of the data. The location of the data, measured by the mean or median, provides information about the central tendency of the data. The spread of the data, measured by the standard deviation or interquartile range, provides information about the variability of the data. Histograms can also be used to identify outliers and anomalies within the data. Outliers are data points that fall far away from the rest of the data, and may indicate errors in data collection or measurement. Anomalies are data points that do not conform to the expected pattern of the data, and may indicate the presence of a special cause or unusual event. Furthermore, histograms can be used to compare the distribution of multiple variables. By overlaying multiple histograms, it is possible to compare the shape, location, and spread of the distributions, and to identify any similarities or differences between the variables. This can be particularly useful in identifying correlations or relationships between variables. In addition to these uses, histograms can also be used to monitor and control processes over time. By constructing histograms at regular intervals, it is possible to track changes in the distribution of the data over time, and to identify any shifts or trends in the data. This can be used to alert operators to potential problems or opportunities for improvement. In conclusion, effectively utilizing histograms requires careful attention to the selection of the bin width, the construction of the histogram, and the interpretation of the results. By examining the shape, location, and spread of the data, identifying outliers and anomalies, comparing the distribution of multiple variables, and monitoring and controlling processes over time, histograms can provide a wealth of insightful and actionable information from the dataset. This information can be used to identify opportunities for improvement, optimize processes, and achieve operational excellence.